Hello, sir. Good morning, sir. Hello, good morning, sir.
Also, kindly unmute yourself.
Sir, kindly unmute yourself.
Unmute. Okay. Yes, yes.
Good morning, sir. Hello, good morning, sir.
Also, kindly unmute yourself.
Sir, kindly unmute yourself.
Yes, yes.
Sir. Hello, good morning. चलो It is my great pleasure. रावत ने छोड़ Okay. It is my great pleasure to introduce your esteemed speaker of this session, Professor N.K. Sharma. He is presently working as Professor of Physics and has also served as the former Dean, College of Agriculture, Engineering and Technology, Etawah Campus, Chandrasekhar Azad University of Agriculture and Technology, Kanpur, Uttar Pradesh. He has made significant contribution of teaching, research, and academic administration. As has vast academic experience, has been a source of inspiration to students and researchers. Today, he will be delivering a talk, Solar Energy Prospects and the Challenges. We are the confident that his lecture will be both informative and English. I kindly request everyone to join me in giving a warm round of applause as I invited Professor N.K. Sharma to deliver his lecture. Thank you, sir.
Thank you, Dr. Ajay. Am I audible?
Yes, sir. Yes, sir. Please continue.
Okay, good morning to all. Especially, I would like to thank to organizers, especially Dr. Ajay Kumar. He is my colleague, so it's a long time back. And also the organizing secretary of this event or the convener, Dr. Prerna Sharma. I also have a long association with him when he was in SRM University. And again, I'm very, very thankful to provide me this opportunity to be with you, especially to talk on a very interesting topic nowadays, that is the solar energy and what are the basic challenges and opportunities in this area. So far as my knowledge is concerned, that this particular conference is to be organized, the topic of the mathematics by the Department of the Mathematics. So we all know that the contribution of the mathematics is highly applicable in the area of the renewable energy sector by using the various mathematical tools in context of the optimization of the devices which are based on solar, wind, and other kind of the renewables, etc. So now we come to our presentation. Just wait, I'm just showing my slides. Please you accept the request for screen share. Okay. I think my screen is visible. Okay, okay. So you will go through this slide as Dr. Ajay Kumar is to be introduced about me, that recently I hand over the charge of this Dean Faculty of Technology in this month. And also I have the additional responsibilities of the Dean Fisheries Science, Dean Dairy Technology, and so on. At present, I'm basically working in the capacity of the head department of Computer Science Engineering and Electronics and Communication Engineering. So whatever this first slide shows, you just go to the right side. There are some interesting slides are there, or interesting pictures are there, which is basically representing the renewable energy in the various form like solar, biomass, hydropower, and geothermal. We all know all these things. So, for is concerned to the introduction about this renewable energy, you people know that India is rapidly transiting towards the renewable energy. Why it is so? Because we all know that in addition to the other parameters, once we compare the developed country and the developing country, then the energy consumption per capita is also a best index parameter to judge whether we belong to the developed country or the developing country. So far as concerned to the scenario of the energy production as well as the consumption, really have a very troubleshoot nowadays. Because so far as concerned to the production of the energy or the electricity as well as the consumption is having a very wide gap nowadays. That's why it is quite essential to us to come to the new kind of the thinking, that is the transitioning towards the renewable energy. That is basically the interest of our us. So renewable energy, we all know that that is basically a kind of the energy which we derive from the natural resources that are constantly replenished, and it is also a key driver for the energy security, sustainability, and the climate action. These three important points are very, very interesting, like security is concerned, sustainability is concerned, and the climate action is concerned. So on the right side, we have to show a beautiful picture that is basically showing that horizontal layer of the different solar panels from or through which we are getting the direct electricity. So that is something about the introductory part of this presentation. That is why we people are interested in the renewable energy, what renewable energy is, and what is the important key driver in this energy sectors. Again, different types of the renewable energy, all of you know. That is the biomass energy, hydropower, we are getting the wind and geothermal. And especially on the right side, we shown that is the solar energy. And today's my presentation is totally focused on the solar energy, its challenges and opportunities. You just go through this slide, it is quite informative. We have shown here a picture of a sun. That picture is basically derived by the NASA scientist, and it is a active sun picture. Because when we have to think what is sun is, we all know that it is a God-gifted star, which is basically lying in our solar system. And I think it is very close to the Earth as per the literature is concerned. So that is the active sun. Means sun is basically found in two modes, active and passive mode. So that picture is basically showing some kind of these spots are basically visible in this sun. So we can say it is active, or you can say it is violent, and number of phenomena is happening at the sun, which is to be considered as a active sun is there. Now, once we are having the sun, it is a God-gifted thing. It's a star. We know that what is the basic difference between the star and planets. When we talk about the star, they are the self-luminous bodies. And once we talk about the planet, they are to be illuminated by the light from the other stars. So sun is a kind of the star we all know. And it is a very good electric power station in our solar system. Like the Panki solar power plant in Kanpur, there are so many power plants are there which are totally based on this water, and some kind of the other uses are there. So why not we have to think, this presentation is totally focuses about the solar energy, and why we people are not thinking about this natural solar power station, or we can say the powerful energy source which is basically lying in our solar system, that is the sun. So Once we have to think about the different parts of this, like this Earth atmosphere, Sun is also have its our own atmosphere, which is having the different layers. That is, first of the thing is regarding the Sun, it is having its internal core, which is having a very high temperature inside the core. So we can say, because it is so affectionate star, which is providing the enormous energy, or it is a very powerful energy generation unit in our solar system. So we must go to the small biodata or small informations about the sun. That is, the source of energy in the sun is considered as a core. Its diameter is too much large compared to the earth diameter. It is 120 times greater than the earth, and roughly it is of the order of 1.39 into 10 to the power 9 meter. Distance of the form is 93 million miles. It is very close to the earth. And one very important thing is that what is the central density of the sun? It is roughly about 100 times to the density of the water. And this is some kind of the information. And the interior core temperature is very high. And the central density is very high. And once we think of about the composition point of view, the major composition in the core of the sun, this is the hydrogen. Other traces is also there, but there are very few percentage there. But the majority of the composition inside the core of the sun is hydrogen. Now, energy, basically it is released in space from the sun. In which form? That we all know, that is in the form of the electromagnetic radiations. Electromagnetic radiations, we know, those people who are attending this conference are having some science background. Naturally, it is having, because it is to be organized by this mathematics department. So the mathematics as well as the science is having a very close relation. They all know that this electromagnetic radiation having the unique, properties. That one of the important property of the electromagnetic radiations, we know that they don't require any kind of the medium for their propagation. This is a very important thing. Also, another interesting information in connection with the electromagnetic radiation is that the speed of propagation of these radiations are, that is velocity of light. So whatever the energy is to be released from this power station in the solar system, it is basically in the form of electromagnetic radiation. So that basically represents the entire electromagnetic radiation line from the visible light to the X-rays and to the radio waves. So there is a wide energy spectra is there, which is emitted from the sun. On the right side, I have shown, this is the very interesting picture that is showing a visible range of this energy radiations which we are getting from the sun, or energy which we are getting from the sun in the visible region, that is 400 nanometer to the 700 nanometer. And on the right side, it is extending to the long wave radiation. In the left side, it is to be extending to the short wave radiations. So it is to be cover up a very wide energy spectrum that is lying basically on this electromagnetic energy, and that is a natural gift. We don't are basically having any kind of the expenses on that for getting this kind of the wide spectrum from the sun. But still, we in the long time back, we are not familiar well, but in last few decades, there is a great progress in science, especially a new sciences to be developed, that is to be called, it is solar physics. So that is the thing, is that sun is not only emitting a very few amount of the energy, but the total electromagnetic radiation part in the form of this long wavelength as well as short wavelength. On the right side, infrared region is there, microwave region is there, radio waves, and so forth. The left side is UV and X-rays, gamma rays, and so on. So this is the another interesting beauty. Now you come to point that what is the basic micro mechanism which are basically responsible for the generation of the energy from the core of the sun. As already I have highlighted that the central core or the source of the energy is the central core, where the density is very large and it is having a plenty amount of the hydrogen inside this core, and the temperature is very high. So you know that we have a very basic process. Or a question maybe arises that what is the basic mechanism which is responsible for generation of the energy in the core of the sun? So that is very simple to understand. It is nothing, but simply it is a very basic process, that is hydrogen fusion, or we can say it is the thermonuclear fusion. So what is the important requirement of the fusion? For fusion reactions, chemistry says that it requires a high temperature, it requires a high density. All these type of the requirement is basically fulfilled by this natural gift or from the sun. Means this density is very large, temperature is very high, so these thermonuclear reactions are takes place in the core of the sun. And what happened in the left side, we have to show the nuclear synthesis, or what is the basic synthesis is going on at our sun. So we are just having that this two lighter nuclei, that is the hydrogen nuclei, is come together and they get fused, or the nuclear fusion is takes place, and we have to get a big nuclei. And ultimately, in this formation, we have to got a mass defect. And once we multiply it by this velocity square, then that is basically responsible for the energy, that is E equal to mc square. So that slide is very quite informative, as we are talking today about the solar energy. So we should know this goddess, star in the solar system, which is having a high beauty, high interesting information, which is basically responsible for the energy generation in the core of the sun. So for is concerned to the different layers, it is having a different layer, interior core, then photosphere, then chromosphere, then corona. So corona is basically the outer layer of the sun in which we all people are living. So that is some kind of the informative slides to understand basically that what is the basic mechanisms which are responsible for the energy generation in the core of the sun. Now, basically, so far in context of the India, what are the important pillars of the India's renewable energy? So we can say that in context of our India, the solar and wind, these are two important pillars of the India's renewable energy. Solar energy, as I discussed, that boasts one of the world's fastest growing solar capacities, which is basically driving by the favorable policies and declining cost, large scale solar parks and rooftops installations. They are transforming the energy landscape. And another one is the wind energy, that is with extensive coastline and windy region. So that is why those who are the researchers are joining this important event, if they are interested in the area of the renewable energy, then before implementing or before utilizing the solar energy and the wind energy, you try to know that whatever the site you are selecting, whether this belongs to the windy area or not. So in context of the coastline or these coastal areas, this wind energy output is very good. And our so many initiatives are going on by the Ministry of New and Renewable Energy, just installing the wind power station as well as the solar energy related program. So these two important pillars are very, very important in context of this renewable energy in India. That is called it is the solar as well as the wind. Now, this is the information that what is the basic significance of this renewable energy in making a greater, greener India. So we all know that that kind of the natural God gift, or that is the renewable energy or the solar energy, which is a very powerful energy source in our solar system that basically reduces the greenhouse gas emissions, or whatever the renewable energy generates electricity without burning the fossil fuels. That is significantly cutting the carbon dioxide and other harmful emissions, which are basically a contributor parameter to a climate change and air pollution. And you all people know that this climate change is not a issue in India, but it is a global issue nowadays. So that's why to resolve this issue, this adoption of this renewable energy, or this energy which we are getting from the renewables or the natural resources like the solar energy, etc., it is highly useful just to solve this climate change issues and other kind of the air pollutions. So that also promotes the energy security, because India improves a large portion of the fossil fuels. Using domestic renewable sources reduces dependency on imports, enhancing energy independence and the national security. So that is another context, or another useful aspect of this promoting of this energy security. And now this boosts rural development. This is also a kind of the significance of the renewable energy in making greener India. That is the solar pumps. It is a very, very interesting agriculture applications nowadays. And there is a important, government initiatives that is under PM Kusum Yojana. Our farmers are to be granted the different solar pumps they can install by getting the so many, important subsidies from the government level. So that is an important boost. That is the rural development point of view. This is also a kind of the significance of the renewable energy in making it greener India. Mini grids, biogases plants which can bring power to remote villages, improving educations, healthcare, and economic opportunities. So that is quite important. That is in context, because this conference is to be organizing in an agriculture university. So that's why this boost rural development is a very important initiative for agriculture universities. So that's why this adoption of renewable energy should be promoted in this part. Now, another significance is the employment generation. It is also a kind of interesting, significance of this use of renewable or the solar energy, whatever it may be, that renewable energy projects, which are especially related to the solar and the wind, that is creating the millions of jobs. And these jobs may be related to a kind of the installation, manufacturing, that may be related to the operation and the maintenance sectors. So new kind of the employment generation possibilities is also a kind of significance of this use of renewable energy. Now the protects natural resources. Renewable energy sources, they basically use the minimal water and cause less ecological damage compared to the coal mining and thermal power generation. What is the conventional method we are using nowadays for the generation of the power? They are using a lot of water. So renewable sources use minimum water use, and that is also a very interesting step, or the very interesting significance of this renewable energy. Now supports India's climate goals. It's also very interesting because right now I say that this climate change is a very, very interesting issue nowadays at a global level, and especially in this agriculture sector that is having a high impact on this our agriculture. So really this uses or the adoption of this renewable energy or the solar energy, it basically helps India's meet its Paris Agreement commitment, that is reducing emission intensity by 45% by 2030 and achieving net zero by 2070. This is the India's green ambition. Because organizer, may I ask that how much time you have given me? Hello?
20 minutes.
20 minutes more. So, okay, accordingly, yes. I have to bind up my presentation, no? Okay. So that is a kind of India's green ambitions, and why that is really matters to us. Again, climate commitment, energy security, economic growth, that already I have discussed with you in detail. This is some kind of the energy mix. India renewable energy mix is there, and it is a kind of information which obtained in 2024. So ultimately, by throwing this picture, we can say that the solar power basically having a high renewable energy mix, that is about 54.99%. And second to that, it is the wind, 33.28%. And the remaining part is showing on this, that is the biomass cogeneration, non-biggest generation, waste to energy, waste to power, like that. So ultimately, as already I showed, the two important pillars in Indian context, that is the solar as well as the wind. So we have a lot of opportunity in this area to work, either in solar as well as to the wind power. That is some kind of the informative slides. That is what is the installed renewable energy capacity. That is April 2025. That is the total installed capacity is 420 gigawatt solar power, 82.63 gigawatt, that is 19.7%. As already I told, next to this it is the wind, and the large hydro, bioenergy, small hydro, and total renewable energy excluding nuclear is 190.93 gigawatt. So that is some kind of this numeric values. which basically showing the kind of installed renewable energy capacity. This is a trend, some kind of the trend, that is a solar CAGR greater than 30%, wind it's 8% targeted by 2030, that is 500 gigawatt non-fossil fuels, including 280 gigawatt solar, 140 gigawatt wind, 60 gigawatt hydro, and so on. State-wise progress, we can go through the light that what the state-wise progress is concerned. In Rajasthan, 22.8 gigawatt solar and 5.1 gigawatt wind, that is the installed power. In Gujarat, it is 10.6 gigawatt. In Tamil Nadu, regarding the solar, it is 6.7 gigawatt. And Karnataka, it is 8.2 gigawatt. And Maharashtra, it is 3.6 gigawatt solar. So that's why this is some kind of the state-wise progress, which I have to present it here for our new researchers, especially in the area of this renewable energy. Now, these are some government initiatives. PM Kusum Yojana, solar park schemes is there. PLI schemes for solar is there. Ultimately, efficiency solar PV module in India and reducing the important dependencies in the area of renewable energy. So this wind solar hybrid policy is there. Rooftop solar program is there. And I would like to share here that in the last year, as a dean, we have to submitted the two proposals to the government, especially for the engineering faculty as well as to the fisheries faculty. So we got the grant for this rooftop solar program to the government, which basically aims to increase the adoption of the solar power on this residential rooftops. So we should be proceeding these type of the programs which is to be launched by the government level or the government initiatives in the awareness as well as the adoption of the solar energy, or the rooftop solar program is a very interesting program of the government. I think all our institutions are adopting that, and those who are lagging behind, they should come forward in this direction. This is again a key policies. India basically robust policy environment that provides strong foundation of the renewable energy growth, attracting investment and fostering innovations. That is the National Solar Mission that is accelerating solar energy deployment through the various incentives that the scheme has already have discussed. Renewable purchase obligations mandating the power distribution companies to procure a percentage of their electricity from the renewable sources. So these are the renewable power purchase obligation is there. These are the regulatory framework that driving the green shift. Green energy corridor, develop the dedicated transmission infrastructure to evacuate the renewable power. So it's a very interesting slide. I mean, just go through this. Number of key policies are there, or the regulatory framework is there, which is basically driving the green shift. Now, I would like to come to our point that regarding solar energy, we have discussed a lot that what solar energy is, how it is to be obtained. Enormous amount of the energy we are getting at a free of cost. But here, I would like to focus especially that what are its prospects and the challenges. So this energy, once we have to say about the solar revolution, solar energy that is basically emerged about the most promising renewable energy sources, which is offering a clean, sustainable power for our planet future. As technology advances and the cost decline, so solar power is basically transforming how we generate and consume the electricity globally. So nowadays, this solar revolution is promoting day by day. A separate ministry is working at a state level as well as at the central level. It is totally involved to the solar revolution as well as the wind revolution. So this basically presentation examines both the tremendous opportunities as well as the significant challenges are concerned, which is facing in the solar energy adoption, from technological innovation to economic. I have to highlight here that what sort of the opportunities as well as the challenges are there. They are basically concerned to the solar energy adoption. What are the important constants for the technological innovations? What are the constants related to the economic consolidation and environmental impact? So these all are the key domains in which this presentation is to be concentrated. As already I have discussed, number of technology. That is a photovoltaic technology, very popular technology, which is basically able to directly convert the sunlight into the electricity, and by using the semiconducting materials. That is a very, old technology, that generates basically the electric current which is to be exposed by the light. We all know photovoltaic technology is a very, very interesting technology nowadays. And these are the panels which are showing in the slide. This totally work on this photovoltaic technology. Now, another important technology is solar thermal system, which basically what happened in this solar thermal system? They captures the light or the heat from the sun to generate the steam, which basically drive the turbines, and that is producing the electricity on a large scale. So these are two popular technologies, photovoltaic as well as the solar thermal. And the important thing is, in context to this understanding of the solar energy, is the energy storage. So very, very, interesting issue in this understanding or the solar energy is concerned. Advanced battery system store excess solar power for use during night time or the cloudy conditions, because we all know the climatic pattern that every time we are not able to get the sunlight. That's why this part is very, very informative or the important from research innovation point of view, that we have to develop a highly efficient energy storage devices. So this is basically the total picture of understanding of this solar energy, or what kind of the important technologies are in use nowadays. That is the photovoltaic as well as the solar thermal, and energy storage is still a very, very open challenge and the open area of research domain in this particular sector. That is the global solar capacity growth. You see this bar diagram is showing that it is continuously increasing. Global solar capacity growth is continuously increasing. So that's why that is the supportive programs from the government as well as to our researcher, our corporate sectors, they are totally involved in that. And ultimately the output is that the global solar capacity growth is continuously increasing year by year. Now, so far as concerned to the prospects, which is the important, specific point of this presentation, and this prospects of the solar decline cost. You see that the solar panel prices have dropped by over 90% in past decades. This cost is decreasing and making this solar energy increasingly competitive with fossil fuels, because we people are totally dependent on this fossil fuel-based solar energy. That is why this becomes a highly competitive. That is, solar energy increasingly competitive with the fossil fuels. So that is one of the very important key prospect of the solar energy. Now, second one is the technological innovation. Right now, in this solar photovoltaic technology, which is a very, applicable technology, which directly convert to the solar energy into the electricity, which is totally based on silicon material or the semiconducting material. But now, in the research domain, the progress is we are having the advanced materials that are like this perovskite cells and the bifacial panels, which basically are pushing the efficiency boundaries beyond traditional silicon technology, which is very less. This silicon technology is having a very, very low efficiency to converting the sunlight into the electricity. So nowadays, this technological innovation or the technological boost or the technological growth is also a very key prospects in context of this solar energy. Now, this energy independence, solar power basically enables the nations and the communities to reduce the reliance on imported fossil fuels and enhance energy security. So energy independence or this energy security is also a very important, or you can say the considerable prospect for the solar energy. As already I have discussed the job creation, it may also be considered as the prospects. Solar industry, there are so many, competitive design, competitive compact design. They are to be basically has to be having a long, competition in different manufacturers. So there is a job creation opportunities are there. Solar industries which are creating the millions of jobs globally in manufacturing sector, installation sector, maintenance sector, and research sector. Research sector is also a very important sector for this opportunities or the prospects of the solar energy. So many, scope is there. Ultimately, what is the issue nowadays? to increase the efficiency of the solar cell or to increase the efficiency of the solar panel. That is how we can convert, how we can get the maximum light. So that is a very important issue. So in the so many varieties of the sector, this job creation is also a very important key prospects of the solar energy. And now last, that is the climate action. This solar energy is basically significantly reduces the carbon emission, that's playing a crucial role in combating the climate change and meeting global targets. So climate change or the climate issue is basically is to be reduced up to an extent by considering the important prospects of the solar energy, that is the significant reduce of the CO2 emissions is possible by adopting this solar energy. So these are the important prospects of the solar energy, very attracting prospects. And you can imagine that this why we people are not interested to this natural God gift, or that is the very, powerful energy station in our solar system. That is the energy which is to be generating in the core of the sun. So these are again very important prospect of the solar energy is there. Economic benefit is shows 85% cost reduction, global jobs and market values, as already I discussed. Environmental impact, because nowadays you just try to, I have just attended the various meeting, various forums. There is a very, very debatable question nowadays that how we can protect our environment or the environmental impact we have to consider of the solar energy implications. That is positive contribution, zero greenhouse gas emission. Once we have to operate either the solar power station or we can operate the wind power station, minimum water consumption, reduce air pollution and improve public health, and preserves natural resources for the future generation. So these are the solar energy basically represents the one of the cleanest forms of power generation with life cycle emissions significantly lower than the fossil fuels. So very interesting thing is that the environmental impact is concerned. So the positive contributions are there. Now, this slide is basically concerned or it is directly related to our presentation. That is what are the major challenges facing in the area of the solar energy or in adoption of the solar energy. That is a very important slide. That is intermittency issues. This is a major challenge which is to be faced by the solar energy sector. That is solar power generation basically depends on weather conditions and daylight hours. That's creating supply inconsistencies, which basically require the backup system. So ultimately in our last slide, I have to giving you the information that this energy storage, we should develop the high power energy storage system. So this intermittency issue is a very, very major challenge which is to be faced by this solar energy adoption. And we have to think about it. So these challenges, discussion of these challenges in this presentation is very important for our future research domain, or it is a very, very challenging aspect for our corporate sector also. And people are working on that and they are involved. Exactly. Storage limitation is already I have discussed with you. Current battery technology remains expensive and that is having a limited capacity. So ultimately making large scale energy storage challenge is a very big issue in this area, or that is a major challenge in facing the solar energy. That is storage limitation, already I have highlighted. Land requirements. It is also a challenge for facing the solar energy. That is large solar farms require the significant land area and potentially competing with agriculture or the natural habitats. So this land requirement, no doubt, when we have to install here the solar plant as it is to be seen in this slide picture, that the large area is to be required. Grid integration. It is also a major challenge for facing a solar energy. That is existing electrical grids need substantial upgrades to accommodate distributed solar generation and manage the variable supply. So I think these challenges are basically open a new route to our all researchers, those who are involved in the area of renewable energy. That is intermittency issues and the storage limitation is a very, very challenging issue in adoption of the solar energy, in which the people as well as the government is also having a serious effort in this context. Technical and the manufacturing challenges. You just go through this slides. It's very important that the efficiency plateau is there. What it says that the most commercial solar panels achieve only 50 to 22% efficiency. It's very low with theoretical limits, constraining the further improvements in that. That's why the biaxial panels and the other kind of the materials we are searching for just making this solar panel. So this is one of the important, technical and the manufacturing challenge in context of the solar energy. That is, they are having a very low efficiency. Now, this manufacturing impact, that is a solar panel, that is production requires the energy intensive processes and rare materials, creating environment. Now, recycling difficulties is also a kind of the technical challenge. That's end of life panel disposal and recycling infrastructure remain underdeveloped. That's very important issue from the technical point of view. That is, ये जो लाइफ पैनल है आपका डिस्पोजल का, उसकी रिसाइकलिंग इंफ्रास्ट्रक्चर अभी भी बहुत मैच्योर स्टेट में नहीं है. That's why we have to work on that. That is potentially creating the future waste problem. So now we should keep in mind, we should know that what are the important technical as well as the manufacturing challenge in context of this. So this efficiency concern, now by using the advanced materials, as already have discussed on our slide. So these are our path forward. 24-26 enhanced storage solution and smart grid integration. If possible, up to 27-30 next generation solar cell, which will be achieving around 30% plus efficiency. It may be possible, the outcome may be by this present efforts. 31 to 35, the widespread adoption and circular economy for the solar material is a kind of possibility, or it's a path forward. Now 36 to 2040, the solar as a dominant global energy source. For the solar energy source with the full grid integration is a kind of the possibility. So despite challenges, solar energy prospects remain bright. Continued innovations, policy support and investment will drive the transition to a sustainable energy future. So this is all kind of the path forward, or it is quite informative, and the future will tell that what will happen. I have the positive hope in this regard. Up to the next generation, solar cell will definitely get the 30+% efficiency. And finally, I have to bind up this presentation again. I have a summation that we should try to know that in context of the solar energy, what important challenges, what important prospects of this energy is there, and why we people are not interested. Ultimately, through this presentation, I have one most important appeal, that at least to each and every participant, those who are joining this conference, they should try to adopt a solar power alternative, at least at their home, as well as once those who are involved in the agriculture farms. So that will be a final conclusion of my talk for this today's presentation, this adoption of this solar energy, as well as challenges and important prospects. Thank you very much. I think if any kind of the query and the question you have, you may discuss with me. That we have a very interesting area of the research nowadays to increasing the efficiency of the solar panel, which is a very major issue in the adoption of this, especially the solar energy. Thank you very much.
Thank you, sir. Any question, participant? Any question?
Yes, sir. Good morning, sir. Sir, I have a query.
Yeah.
Yeah, okay.
Sir, first of all, thank you so much for the informative talk. It is very relevant in the current scenario. Sir, I have a question that we are talking about the solar technology. And if we talk about two different regions, one that is hotter and other one that is cooler regions. So
Okay.
if we are dealing with a material, then how its efficiency will get affected in these two regions? And if it will get affected, then how we can tackle it?
Okay, it's a good question you have asked. That you just want to operate the system in the cooler as well as the hot regions. Okay,
Yes, sir,
so
in two
no
different
doubt.
countries, or we can say.
Okay, so no, what you think that whatever the materials, basically, as already I've discussed in this presentation, that ultimately in this photovoltaic technology, the role is the material. So whatever the material we have to develop, especially for these cooler regions, that should be some kind of the separatist specific properties. Okay, if these properties are to be sustained there, then they will be response accordingly. That totally depend on like that. Otherwise, whatever the material we are using, that totally is to be concerned to the sunlight, not to the cooler as well as to this warm regions. Whatever the sunlight region is there, or the major sunlight insolation you have to adopt this solar system there. So that is the thing is.
Yes, sir. Thank you, sir.
Any question, other participant?
But ultimately, through this presentation, I request to all of you that at least at your homes, you try to adopt one solar power for your personal use. Okay, you will be see that definitely some changes will be arrive. Whatever we are talking about this CO2 emission, reduce of the CO2 emission, but most of the people still we are dependent on whether the light is coming from the station or not. So try to adopt it at your roof, at your homes, at your institutions, etc. Thank you very much.
Okay, thank you very much, sir. On behalf of the organizing committee and all the participants, I sincerely thanks Professor N.K. Sharma, Professor of Physics and former Dean, CAET Etawah Campus, Chandrasekhar Azad University, Agriculture and Technology, Kanpur, for delivering such an insightful and enlightening keynote lecture on the solar energy and prospect and the challenges. Sir has beautifully highlighted the importance of the solar energy in future prospect and the challenges ahead. With a perfect blend, the scientific depth, the practical relevance, the lecture was truly informative, inspiring, and very relevant of the researcher and academies and student. We are extremely grateful to you, sir, for inspiring your valuable time and sharing your vast knowledge and experience with us. Once again, thank you very much, sir.
Thank you, Dr. Ajay. Thank you very much for organizing such a nice event. Okay. You have a very good team now.
Okay.
Okay.
Thank you,
Thank you
sir.
very much.